Good morning, all the students and watchers. Myself, Deepika R, currently working as an assistant professor in the Civil Department, RR Institute of Technology. So today I'm going to discuss about the stiffness method, elemental stiffness method, and that too the problems on trusses I will be discussing. So how to solve the problem by using element transformation method or displacement transformation method. So regarding this, we will discuss today. So for that, I have written a brief procedure over here. You people can see this. So this procedure, if you have solved continuous beam problem, it is solving the trusses is very simple because here no need of calculating fixed end moments because we know that trusses will never carry any moment. So fixed end moments will not be there. If there is no fixed end moment, obviously no need of calculation of P, E, Q, J also. Right? So I'll just read out the steps. See the carefully. What they're telling first, you have to find the length and angles of the number if required. If it is given in the question directly, no need to calculate. If length is not specified, see sometimes only one single length will be given and angle will be given because you want all the member length. Okay, at that time, what you have to do, you just see the diagram carefully and calculate length and angle for all the members like A, B, B, C, C, D. So many members will be there. No, for all the members you have to calculate. Okay. The second step, degree of freedom. Based on the type of the support of the joint, you will be calculating degree of freedom. So this I'll be telling you while solving the problem. So remember this, the formula for truss stiffness matrix formula will be K is equals to A by L. Okay. Here I'm going to skip fixed and moment calculation because no moment will be there. So directly you should jump into transformation matrix calculation. So what they are telling, how many unknowns will be there? Like here you can see this. By giving unit displacement along system coordinates one at a time. System coordinates means number of unknowns. Based on degree of freedom, you're going to fix the number of unknowns, right? Like theta A, theta B, theta C. So those are system coordinates. Whole system, if you take some coordinates, you are going to get. We will be calling it as system coordinates. Here, we will not be talking about. Sorry, we will not be talking in terms of theta values. Instead of that, here we are going to discuss like horizontal force and vertical force. For horizontal force, I'm going to give a notation U, and vertical force will be giving a notation V. Okay. The rest of all the formulas will remain same as continuous beam problem. Um, if you have not solved the continuous beam problem, please try to solve continuous beam problems first and then come into trusses and frames. So I'll just move on to one simple problem. Third one I'll explain today. So see this, what they're telling. Just you need to analyze. Analyze means you have to find out what is the member forces in all the members. How many members are available here? You can see here A, B, C, B, C, and B, D. Totally three members are available. Which method? Displacement transformation method. They may give you like element stiffness method or displacement transformation method. Okay, this is the given data for you. See, this 2.5a to a inside the bracket, whatever I have written, it's not given in the question. So be careful. Uh, First, what we have to do, we have to check whether all the length and angles are given. You just check now. Angles are already given, so no confusion. Only vertical length is given here. So, but the members BC and BD are inclined, right? So what you have to do, find out the length for member BC and BD. So calculation I have done in next page, I'll show you. Before that, just see the degree of freedom. Fixed ends, we know that there is no freedom is allowed because it's already rigid in all three directions. How many directions are there? Vertical, horizontal, and one more is rotation. It's fixed in all three directions, so the value will be zero, right? This is also fixed end, so 0, 0 and 0. This is the only joint left which is having freedom, that is joint B. No rotation here because it's a truss problem. In case of frame, you have to consider. Okay. So now there is only joint left is joint B. We know that there will be two reactions. I'm going to call it like UB. This is my first unknown, and the second one will be BB. Okay, that is what I have written here. UB and BB. Okay, these two are my unknowns. And the next step, what I have to do, calculation of stiffness matrix we should do. Formula is A by L. So here you're gonna need the value of length. For that I have done a calculation over here. See, instead of writing B here, I think everywhere I have written A. Please don't get confused. This is B and this length is BC. Okay, or else you do one thing, you just replace instead of A, you replace with B. Okay, the middle one you give joint A, then there will be no confusion. So middle one, now it is joint A. You just check the value. What is this? From AOC triangle, angle is already given, vertical length is also given. So apply Pythagoras relation or as sin theta, opposite by adjacent, you are going to get AC and AD. The signs I have replaced here, the middle joint will be joint A. Okay, it's not B because in the next in the answer I have written like AB, AC, AD only. So please don't get confused. You just replace it. So calculate AB, AC, AD number individually. These are unassembled stiffness matrix. Assemble it in a diagonal format. So once you assemble it, this is the end of the transformation, stiffness matrix set. So once you got Km value, you just move on to your transformation matrix calculation. This is a very important step here because most of the time we will make mistakes here. See this carefully. Same diagram I have rewritten. I'll show you. Okay, the same diagram is rewritten one more time. You can see here this is UA. Okay, the middle joint is A now. I have replaced, and this one is VA. Okay, how to do this? So what I told, when you're going for a calculation of transformation matrix, how many unknowns will be there? You have to consider all of them individually and give unit displacement or unit value. That means 1 kilonewton I'm going to give here. Okay, give 1 kilonewton value and check out what is the force you are going to get in all the members. So before doing that, what you have to do, you just extend the original member. I'll call this as C dash. Okay, and this one as D dash. To avoid the confusion, I'm giving different notations. Okay, see now, the joint A is going to be pulled by how much? 1 kilonewton. Because of this pulling, what happens to member AC, AD and AB? We are going to check now. Okay, when you are pulling this out, obviously these two forces should go out only. No, it will not come towards joint here. See, arrow mark is going out here. So your D dash and C dash or arrow mark must go outside. So what does it mean now? That means when you're going to apply the force UA from the joint A, you are developing some force towards the original member. Getting? See, 1 kilonewton I'm applying for joint A now. Because of this 1 kilonewton, AC, AD, AB member will also affect it somehow. What is that effect? That is AC dash and AD dash. The original member must withstand this effect, right? So that is why what we have to do, we have to give take the reaction or answer will be in opposite direction. Are you getting? So whatever the arrow mark you're going to get here, if UA is going outwards, this arrow mark will also move outwards, right? Based on that, D dash is written. But in opposite to D dash, you have to write the arrow marks on original member. Is it clear? So now see C dash is going outwards. So opposite to that, that one I will write like this. I hope you people understood. See, U is pulling joint A outside. Because of that pulling, you are going to get two extra member forces, or else effect you are going to get. All those effects you have to write by extending original members. Whatever the arrow mark you are going to get on new member or as a new force, exactly opposite to that you have to mark. No need to mark anything on AB because it's already, what is the angle? 90 degrees we are getting right now. So I'll write this first one. Answers I'll write. Just see carefully. First I'll write AB. Okay. So AB is equals to how much force we are applying? 1 into adjacent angle only I'm taking. So I'll be going with cos 90. Angle is 90, no? So cos 90 is 0. Answer will be 0. Next, look at AC dash or AC, whatever you want, you can write. AC arrow mark is going away from the joint, that means it is a tension, right? If arrow mark is moving towards the joint, it will be a compression. If arrow mark is moving away from the joint, that will be tension. Okay, remember that point. Into cos, what is the angle? I think 30 degree, no? Here 30 degrees there. Uh, so this will also be 30 degree, right? So here AC I will write down. AC is equal to 1 into cos 30 degree. Check out the answer, how much it will come. Just write down. Next, AD equals, here negative sign I will write. You can see here the arrow mark is moving towards joint B and joint A, right? So it will be a compression. 1 into, if you are taking adjacent angle, the angle which is adjacent to UA, if you are taking like that, you just write cos. If you are taking the another side, I'll show you. So I hope this one people got no cos 45 writing. Just check out the answer. See now, uh, this is 90 degree, right? So in between you are getting this AD dash. What I'm doing, I'm taking this angle. This one I'm taking, that is 48.5. How I'm doing the calculation? See, this 48.5 degree is adjacent to this UA. Okay, that's why I'm writing cos here. If you are considering the opposite angle, which is connected to y-axis, then here you have to replace with sine. So be careful. For whatever, like if you are taking an angle adjacent to the unknown displacement, like UAVA, you write cos. If you are taking an other side, you have to write sine here. So here I'm going to write sine. Just check that. So this side is 30 degree, right? And this side we are going to get 48.5. This is 48.5 and this is 30 degree. So obviously I'm going to get like this right now. So now you tell me the answer. What I have to write? This is AC dash. Here only I will write. So 1 into which side you are taking. See, VA is here. But angle I'm going to consider the opposite one. That means I have to write sine here, sine 30. Okay. So here also 1 into sine 48.5 I will be writing. So VA is running along AB member. So either you can take 0 degree or 180 degree. See, if they are in a same line, always you just take 0 degree. So this will be 1 into cos 0. Okay. This one you got because this is a major step here. Have a clarity with angles, how to write sine and cos. So this is an example for writing a cos, and this is an example for writing sine. Just go back to the notes. See here, sine and cos, the both I have used here. Please check the calculation, or else you both I have written. See, 1 into sine 30 you can use, or else 1 into cos 60. So if you're taking this side angle, you should write 60 degree. Okay. So check the calculation. First unknown will be UA, and the second unknown will be VA. Based on the members, how you are considering the same order you have to follow. AB, AC, AD I have written. Don't get confused. AB is here, so 0 is substituted. AC 0.866 and AD last one minus 0.662. In the same way, VA is also substituted. So writing force matrix, we already know that DS is a notation for displacement matrix. So there are two unknowns available for us, UA and VA. I have written. What is PS? PS is a force matrix. We already know that formula is PS is equals to PEQJL plus P external, right? Here PEQJL is not there because no fixed end moment. So you leave it. External forces are there, you have to check. You just go back to your diagram. External forces are there. Yes, it is there. Please observe carefully. These two are your unknown. This is UA and this is VA, right? Along UA direction, there is a one load, 30 kilonewton. And along VA direction, there is one more load, 20 kilonewton. Both are running in the same direction as what we have assumed. So I have written positive signs, 30 and 20. You can see here. Both are running in the same direction. No, that is why I have written 30. UA is along UA direction, there is a 30 kilonewton is there. Along VA, 20 is there. The rest of them is just a calculation. Just apply to the formula. Find out global stiffness matrix. Once you got global displacement stiffness matrix, you can find the displacement matrix and final forces. In the continuous beam problem, you are getting one more extra term here, minus PEQJL, right? So that term will not be there. Only you have to consider Km into T into ds here. So just go through the problem and do this calculation. Writing stiffness, transformation matrix is a very important concept you need to learn here. So try to practice as many as problems. I'll just move on to fourth one. I'll be explaining only transformation matrix. Rest of calculation you can do yourself. See the fourth problem. Find the forces in a member of a joint loaded as shown in the figure. Yes. Use stiffness matrix they are telling, and consider AE as same for all members. So here observe carefully. See this 100 cos 60 and 100 sin 60 was not given in the question. I have written that. Question was given like these three members along with this 4 meter distance and this 100 kilonewton plus 60 degrees. So what we have to do, see this 100 kilonewton is an inclined member, inclined force it is, right? So if you have an inclined force, where will you substitute? So that what we have to do first is just resolve that inclined force into horizontal and vertical member. Angle is already given, so resolve it. This side angle is given, so this side will be cos 60 and the opposite one will be sin 60. Correct, no? So DO F. See, even though it is a huge number, you should not consider any freedom there. Why? Because you are solving a truss problem. In case of the truss, moments will not be there. So you have to be very careful. See, obviously, hinge will carry one vertical and one horizontal. Many of the students will think that okay, moment is not there, so it is having the freedom one. It is a wrong concept. So moment will not exist only. Okay. So what you have to do, one horizontal and one vertical is already there. That means it is stiff now. It's a truss, no. So here you're going to get freedom as 0. In the same way, joint D is also having 0 freedom. You're not allowing or you're not giving any freedom at these three joints, which is only joint left for us. It is a joint A, right? So in the same way, joint A is having one horizontal and one vertical. You can assume in whatever the direction you want. If you want, you can assume towards left also. It is not a standard, whatever I am assuming. So this will be UA and this will be VA. These two are my unknowns now. So that's what I have written here. Degree of freedom is 2. That degree of freedom is allowed only at joint A, that is UA and VA. You just do the calculation of stiffness matrix, find out the length, angle, and just substitute in a diagonal format. You are going to get stiffness matrix. So let's see about transformation matrix. See the transformation matrix. This is UA, right? Okay. Here UA is given. The arrow mark is going outwards. So extended length, that is D dash is given here. That should also go outwards, right? So B dash will also move outwards. Your C member, AC member is along or is in line with UA. So don't write anything. So what you have to do, exactly opposite to this arrow mark, you just mark here. And exactly opposite to this one, you mark over here. Okay. If you're getting confused, you mark it on both the sides. So what is the symbol? This is tension symbol, right? And this is also tension symbol. This one is also tension symbol because all the arrow marks are moving away from the joints. So everything you are going to get positive values here. Okay. So now check out the angle. This is theta. I think theta is 38.65. You just do the calculations. See, adjacent to this UA, your theta is lying. So that is why I have used cos here. In all the calculation, I have used cos only. Okay? Why? Because your theta is lying adjacent to your UA force. If you are using sine, what you have to do, you can take this theta dash. Getting? If you are using sine, it should not be connected with UA. If you are using cos, the theta angle, whatever you are using, it should be connected to UA member. So now look at this one. Okay, look at VA now. VA have assumed an upward direction. So how many members you can extend? Only D dash. Since UA is going in upward direction, here you are getting your B dash value, right? So as it is, you mark opposite to this arrow mark. So here it is marked. Which symbol it is? The tension symbol. What about this? Be careful with tension and compression. See, this arrow mark is moving towards the original number or the direction of the original member. So exactly opposite to that, here it is marked. Okay, so which symbol it is? Arrow is moving towards the joint. That means it's a compression symbol. Okay, so this is 90 degree you are going to get. No, anyhow, whatever may be the direction, answer you are going to get 0 only. So that is the reason I have not marked. So first one, A dash, B dash or AB, based on your convenience, you can give the notation. So value is 1 kilonewton into adjacent to VA only I have used. That's why cos has been used here. Cos 51.35. So answer you are going to get negative value. Negative value is only because here it is a compression. Okay. See the last one. The last one we are getting tension here. That's why positive is written. Even though same value, positive and negative, you have to be very careful. Okay. Try to practice the problems. So rest of thing is just a calculation. This 50 and 86.5 you're going to get based on the resolution. And initially I have showed the problem. No, see this 100 cos 60 and 100 sin 60 because UA and VA is lying here only. So along UA and VA direction, which force is that you have to consider. Okay, just do the calculation. In the next video lecture, I will tell you some different kind of problems. Thank you all.